Deep.
Charles,
What's up?
how's it going?
It's going great, man.
We've got some big news.
We do?
We're in a new building now.
Oh my goodness.
New conference room.
Look at that whiteboard.
It's nice. It's big.
Oh, I like it.
It's a big whiteboard, and we've got a new face with us.
Special guest.
Look at that. Who are you?
Hi, I'm Abhay. I am working with SFRP for almost now 5 years.
Wow, quite a bit.
Not full, but around 5 years. And so I worked on SFRP, I worked on Linux porting. I worked on many parts of Service Fabric throughout this journey. So it's quite fun to see.
You're quite familiar with various parts of those.
Yes.
So I mean, one of the things that you mentioned was SFRP, and that's what we're here to discuss today.
Sure.
So SFRP, for those of you that don't know, it stands for Service Fabric
Resource Provider.
Thank you. And it's the control plane, basically. It's
control or management plane.
Yeah. So when you come to Azure, right, you can get a cluster effectively for you, which is what we sometimes refer to as an SFRP cluster, or a cluster that's been provisioned through Service Fabric's resource provider. And for those of you that are more familiar with how Azure works, you might know that Azure itself consists of several different resource providers that work together to get you resources when you need them. So when you need a VM scale set, when you need a network setup, there's an RP, CRP, so network RP, compute RP, all of these work in tandem to help stand up these ARM resources or Azure Resource Manager resources that sort of come together. And so SFRP is our resource provider that gets you these clusters. So I want to walk through a very basic scenario with you to kick things off, and then we can delve a little bit deeper into how SFRP works. So to start out with, I mean, the most familiar story for somebody who's starting up a cluster for the first time is they go to portal.azure.com and they go to the marketplace, which is literally you press plus, you're trying to provision a new resource, you find Service Fabric cluster. Then there's a series of questions, and sort of you fill out a relatively complex form that tells us about what kind of cluster you want, what kind of VMs you want. It allows you to toggle a whole bunch of settings, and we'll go into a few of those settings as well. Sure. What happens when that template is validated and I hit create?
So you start by providing bunch of values. For example, you give a cluster name, you provide the resource group name, then you go into the next blade where you select the node type, the number of node types. So currently we only allow 3 node types from the portal, but actually you can go as much you want if you just use a plain ARM template. In those node type, you provide like node type name, you select the VMSS SKU, the OS type, and then you go to the next one, which is like you provide the certificate. So you either create a certificate or you just bring your own certificate and deploy it to the keyword. We pick up 3 values for those, which is like a thumbprint, the resource URL, and then the resource ID. And then the portal does a validation. Behind the scene, they just call a template generator, which basically generates a gigantic template that you might have downloaded, because there's an option to say download template. So that template generator basically shoves separate resources into it just shoves each resource that are required to create a Service Fabric cluster. So for example, you need a VMSS resource, you need the SF cluster resource, you need a public IP, you need the VNets, you need storage accounts. So everything is filled in by the template generator, and all these values that you provide in, they go as a parameter. And then finally you have this gigantic template, which if you download will be like, say, 1,000 lines of code. That confuses people.
That's a long JSON file.
Yes, and it's a long JSON file that gets sent to ARM. ARM in turn extract those pieces, and then there's something called as a dependency graph. So if you say I want a cluster, then we say, hey, for the cluster we need VMSS, And then for that VMSS, we need VNet. And for the VMSS, we also need a storage account to host the, say, the
Diagnostic
OS.
logs.
No, the OS VHDs.
Oh, okay.
Right. So now there is something new called managed disk. So we by default turned on the managed disk. Previously, you might have noticed like you used to have 5 storage account per node type. So the limitation used to be like you can only have 20 VHDs hosted into a storage account per node type. So then that ends up like if you want to go for 100 nodes in a node type, then you have 5 node types. So that's the logic behind that. So now VMSS came up with a new feature called managed disk, which automatically allows you to they automatically pick those 5 and they don't show up into your resource.
I see.
So that's the thing. So then you also have like a storage account for your diagnostic extension, which is called as WAD or Windows Diagnostic,
Windows Azure Diagnostics.
Azure Diagnostic, or LAD, Linux Azure Diagnostic.
Yeah.
Sometimes people use OMS extension.
Yes.
And there are a bunch of other extensions.
Right.
So all this ARM will just take the whole template and will send it to each one depending on their priority, and then once the resource is created, it puts the required values into the new resource.
Sure.
And it sends that request to the other resource. And finally, the resource, all the resources are generated, and you get the resource group deployment successful with whatever the result that is marked as an output response is sent back.
So is it fair to say that ARM is orchestrating a series of different resources
Resource
being
deployment,
provisioned,
yes.
and it's communicating with various RPs to actually pull this off?
Correct.
So it'll first go to like storage RP to get the storage,
Yes.
then probably it'll go to CRP or NRP to get the network provision, and
Yes.
then get the VM
Yes.
skills in it.
Yes.
So why is it that the Service Fabric cluster resource itself is not a cluster? It's just it's an abstract reference, right?
Good question. So normally, like when people deploy Service Fabric cluster, they think that that cluster resource is actually a Service Fabric cluster, but that's not the case. So the cluster is just a representation in Service Fabric resource provider, an entry point which says, hey, this cluster exists and it's supposed to be on these node types, and if anybody come and talk to me from these node types, they need to have this kind of verification through a certificate, and that's it. And then it knows the state of that. So it's just a control plane. The whole management is happening. It's just a management plane. The whole the worker nodes are actually in the VMSS resource, right? So if you look at the cluster resource, it has it generates a cluster ID, and then it generates what type of cluster you're gonna have, which is either Windows or Linux. It's gonna tell you all the cluster manifest definition that it's supposed to have, and then it will have the verification process, which is the thumbprint that is being used for the verification. On the VMSS resource, you will find something called as a SFVM extension. That extension actually contains a bunch of settings which says, hey, when you find a particular certificate of this thumbprint, go ACL this certificate, and then set up these diagnostic related information, and then this will be your cluster endpoint that you will go and talk to. So it defines where SFRP is located and what is the cluster ID that it needs to be identified with. It takes that and then it talks to SFRP. So let me try.
Yeah, absolutely.
So this is a flow. You have template that goes to ARM. Then it has bunch of resources. 1, 2, 3, and so forth. So for example, say VMSS, public IP, storage, cluster, right? So once this gets provisioned, you have a cluster ID generated into SFRP. The response is sent back to ARM, which it puts it into VMSS extension.
I'm going to ask you to write a little bit bigger for the people that.
Sure.
Yeah.
So in SFVM extension, you will find something called as the cluster endpoint. It passes the cluster ID.
I'm impressed you remember all this off the top of your head, by the way.
So once VMSS gets that, it deploys a bunch of VMs. So say you have deployed say 5 node cluster, right? So you will have say VM0, VM1, and so forth, VM4, right? Now on each VM, there is something called as a WA agent. This is a CRP code that gets deployed. It launches bunch of extensions. So you might have like say WAD extension, OMS extension, custom script. All these are bunch of executables that this guy will invoke. This guy will just spin up, right? Then you have let's talk about the SF extension, what it does. So it will take all this configuration and it does bunch of things. So first it verifies that all the provided config is valid. So for example, you have provided a thumbprint, the cert present on the VM.
Sure.
Right? Then the node type, those matches. The third part is you have diagnostic information that is valid.
But this diagnostics is different than WAD. This is a diagnostic.
This is SFRP specific diagnostic. So if you want a support from SFRP, you need to have this. Otherwise, we can't diagnose your failures. And then it also validates the cluster ID. So you can ignore the cluster ID part, but this ties up with what you asked, like which is in past in past people when they wanted to get rid of cluster, what they used to do is they delete the cluster resource and then they recreate the cluster resource using the same VMSS.
Right.
And then in that case, I'll explain what happens, but for that reason we started validating the cluster ID. And then once everything is valid, SFVM extension configures all this part and sends request back to SFRP saying that, hey, this is my topology, which contains the name of the VM, FQDN, UD and FD information. So each VM will start sending this information to SFRP. Once SFRP reaches to the point where it knows all the required VMs to form the cluster have reported, it generates a cluster manifest.
Okay.
And then it also provides the specified SF version, SF runtime version. SF extension takes that, install the SF runtime, configure the cluster manifest for the node, And then once each node boots up, it forms a ring. And that's how your cluster comes to life, right? So in this, you have to take few considerations. So you might have seen like things waiting for nodes,
right,
deploying,
yes,
right?
yes.
All these states are basically when you deploy the cluster resource and it gets generated, but there is no associated VMSS or the topology from all the nodes are not reported, it will be in first state as waiting for node. Once the topology starts reporting, it gets into a second state, which is deploying. Then once all the nodes are reported, during deploying state, there is like all these nodes are bootstrapping. Once the ring forms up, then the third state will be baseline.
Based on upgrade, right?
Yeah.
Cool. Bringing back memories. I'm waiting for my cluster to come up.
Yes.
Looking at the resource.
And then it goes into a ready state. So that's what is happening. So this roughly takes around sometimes ranging from 5 minutes to all the way 15, depending on
all the pieces
stitched together.
So just to recap, I mean, waiting for nodes is still at the point where you're waiting for the SF extension to report all the correct info to SFRP.
Correct.
Deploying is once it's validated and it's providing the right runtime bits.
Yes, so once it generated the cluster manifest in this state,
yeah,
it already generated the cluster manifest and it also provided the runtime.
Right. So deploying is it's actually booting up literally fabric.exe, fabric.host.exe, all those things are happening. Baseline upgrade is upgrading it to the runtime bits that have been provided to make sure that the cluster is running at the level it's supposed to.
So it basically, the cluster marks itself as a starting point, which we call as a baseline upgrade. So it will register the current runtime and cluster manifest version as the starting point.
Oh, okay, so it's not actually doing an upgrade.
It's not.
Yeah, because obviously it's only one version of service like that. Okay, and what else? What happens to the SF extension after it does all this?
The next part of SF extension, it just goes into a monitoring state. So it will just keep monitoring if the Fabric exe is running on the node, and if it detects the Fabric exe has gone down, it verifies if it's because if there is a runtime upgrade, because during runtime upgrade we do take down Fabric exe down, and that time Fabric process will not be present. But if not, then it takes a repair action, which is like it tries to recover the Fabric exe on the node.
But that's similar to what Fabric host.exe also does, right?
Yes, but Fabric host, in Azure environment, there are cases where Fabric host might not able to recover. And that's where you need like external entity which is monitored by the CRP, like guest agent, which allows it to like take extra action. So for example, if the Fabric process is just crashing because say the ring is not forming, the Fabric host will just keep
going up and down,
taking it up.
Yeah.
But then there's something called as the service healing, right? During service healing, what happens is you have a C drive, which is OS drive, which is backed by the managed disk, and then you have ephemeral drive, which is your D drive, where you will find your fab SVC or SVC fab. I keep it's this particular folder. You have your data. Now this
and
is
your log, right?
Yes, and this drive can get completely reimaged during the service healing. So now Fabric host expects your cluster manifest to be present in this drive,
Right.
and it tries to start Fabric with that, and it will just keep filling. So during that time, say extension detects, hey, the service healing happened, I need to recover this machine, so it will just go and reconfigure that node with the data drive, and then it will get the VM up.
Makes sense.
Yes.
So not everybody actually knows what a cluster manifest is, because we don't really talk about it as much, right? Because from a user's perspective, I have my ARM template when I'm deploying to Azure, and I have my cluster configuration.json when I'm deploying to standalone. But some of you guys may have noticed that once you actually deploy a cluster, in SFX itself, you can actually see the cluster manifest, and the same applies to your local development environment, where you can actually go to this folder and you can see that there's a cluster manifest.
Manifest.current.xml.
Yeah. So what exactly is the cluster manifest?
So cluster manifest contains the cluster settings. It defines what are the seed nodes or voter nodes that will provide seed for any incoming node. It also describes, hey, what will be my failover manager configuration, what will be my Fabric host hosting configuration. It just describes the configuration for the whole cluster. It describes, hey, what kind of security I'm gonna have, and what is the thumbprint I'm gonna use for my cluster to make it secure.
It also contains data for some things like reverse proxy port.
Correct. It contains port information. It contains node types that we use. It contains sections for repair manager. It contains section for infrastructure service, and bunch of it.
Okay.
Sure.
Cool. So I mean, two things you just mentioned at the end of that I want to learn a little bit more about.
Sure.
Repair manager and infrastructure service. What are those?
So, okay. So let's talk about the infrastructure service.
Okay.
So infrastructure service is the way we translate that for the external user is by using a durability concept, which is silver, gold, bronze.
Yeah.
Bronze is no durability. You will not find infrastructure service. Silver is durability with I think 10 minutes.
Yeah.
And then the gold is 30 minutes.
Or is it 2 hours?
No, 30.
30 minutes. Okay.
Yes. So what that means is, if Azure is performing any infrastructure upgrade, say it's doing a bunch of reboots, it will.
And then you mean like literally in Azure's data centers, right?
Yes, Azure data centers. Say they're updating their.
Nothing that the
VMs.
user has asked for. It's
Correct.
just imposed.
Like a VM foo.
Yeah.
Yes. So in that case, Azure will come back and ask SF saying that, hey, I'm going to take down this machine, do whatever operations you need to do to make it safe. And I'll give you 10 minutes.
It gives you an option
For
of
silver.
graceful.
I'll give you 10 minutes. You need to finish everything within those 10 minutes.
Yep.
And then I'll move on.
Yeah.
At that point, I'm not going to wait. But if user is initiating some requests, which we called as a tenant upgrade, which say, for example, you are changing your SKU. You are going SKU up, say D2B2 to D4B2. Now that we called as a tenant upgrade. Or you initiated, say, reboot all, kaboom,
Wow.
right? So those are tenant upgrades. So those have infinite MR. So basically, if that happens, then Azure will come back and will wait for SFRP to say approve till it will not go forward. So that's the durability thing. So
Okay.
people normally. If you have a cluster with the silver durability and you might have seen incidents which are like, hey, I'm trying to do a scale up and it got stuck because I did something in the past and my previous job has never gone through, and we are just waiting for that. So that sort of thing.
So the infinite timeout.
Yeah, because say now one of the incidents that I have seen recently, which is user scaled down the node type, the secondary node type, where he had all the applications to instance count 1, and you are left with only one instance. You have infrastructure service on that instance because you have MI, and now they said reboot that VM. Right? And then they said, oh wait, now I want to add more VMs to it, and it's not happening. The reason is that reboot is still pending, and till the MR approves that job, which it will not, because you're literally going to lose the whole state for that service. So it's just waiting that you add some nodes to it.
From the user's perspective, right? Why would I want to? Why was the user trying to reboot their machine? Like, what is the thinking there, right? Because they know they have a Service Fabric service, independent of VMSS, right? So I have a Service Fabric service, and for whatever reason, I got myself into a state where I have one node, as you had just mentioned in the incident report. Why would I then try to reboot it? Like, what was the thinking? What was the root cause in the customer's mind, independent of how Azure actually works?
There can be many reasons why you want to reboot the machine, but simple or the like a straightforward thing is like, hey, for some reason I open multiple file handles, and because Windows is not dropping those file handles, I'm not able to edit any file right now, and I just need to reboot the VM to recover at that point. Because my service outside of Service Fabric is doing something with IO or something with network, and where I end up into a state where I just need to reboot.
Okay.
Right? Because Service Fabric allows you to run any code. Right? So in that code, you can have anything that might.
So if they have an EXE in their package.
Yes. Right? In that EXE, they just randomly opening file handles, and now they're stuck.
Okay. It's interesting. I mean, I see a lot of incidents come through, and we'll be on call in the not too distant future, dude. So this is important stuff, man. So don't do things that are going to keep me awake at night, right? Come on, folks.
Do it for Charles, guys. Do it for Charles.
That was really interesting. I mean, that is interesting to know, like the thinking behind the thinking of when someone tried to just reboot a Service Fabric node. It doesn't matter that VMSS is behind it.
I mean, why is it that we don't?
Let me also capture this part. Like, sometimes we ask people to reboot, and they misunderstand reboot with the Fabric restart. So on SFX, you have restart Fabric node.
Oh yeah.
That command just recycles the Fabric exe. Right? So now, so sometimes you will hear is node up from the Service Fabric folks. They will say is node up. That node up terminology actually refers to Fabric exe or Fabric host, and not the VM. We will say, are you looking at the VM? Is VM running? Then we mean VM. If we say node, it's Fabric exe.
Well,
it's a jargon, basically.
Yeah, but it actually makes sense because the VM is a node in the context of Service Fabric's cluster, which is a grouping of virtual machines. That said, it's a grouping of nodes.
Nodes, but which is a Fabric exe.
Yes. Okay, that's interesting. That might be some more work for Tom to kind of clean up that lingo a little bit in SFX. You hear that, Tom? He's my neighbor. He works on SFX.
Oh, I see. Okay.
Yeah, because you see those drop-down APIs, and you can do restart node, you can do pause, you can do deactivate.
Yeah.
A lot of people think that by deactivating you're actually turning off the node, but really the node is still allocated in the VM scale set. All you've gone and done
VM is still running. Like,
correct. The VM is still there.
People sometimes also have questions like, hey, I restarted this
Right.
node or I disabled this node, so I'm still going to get billed. You are, because you're still paying for the running VM,
Yes.
right? And that VM is, so your meter is running by CRP, which is the compute resource, which is running your VM.
Okay.
I think it's interesting to capture, like, when you look at your VM, what are all the processes that you see, right? So we have service fabric node bootstrapper, then SF node bootstrapper upgrade agent, then you have service fabric installer.
Wow, these are all the processes that are running?
These are a bunch of services. Then you have fabric host, and then you have fabric.
And all of these are on every single VM, every node, right?
On Azure.
Yeah.
And if it's a standalone, then you will find these three.
Right.
If it's Azure, you find these two.
Because bootstrapping is handled differently in general.
Yes.
But here we're focusing just on SFRP.
Sure.
So let's also talk a little bit about upgrades. So you know that when you're creating a cluster, you can set a specific version or you can set it to automatic.
Yeah.
What does that mean? And how does that get played out in the scenario that a new version comes out?
Okay, so when you say, so there are two modes that you can pick. One is the automatic mode, the other is manual mode.
And this is specifically for service fabric upgrades, not for
SF runtime upgrades.
yeah, not for OS upgrades, not for app upgrades, but literally, for example, we're at 6.3 now. We're about to roll out a refresh, so
Yes.
that would be a new version.
Yes.
Yeah.
So when you pick automatic, it basically means whenever the SF updates is config to pick the new default version, your cluster will get and automatically gets upgraded. So if we release 6.3 and you're on 6.2, then your cluster will get a request to get upgraded. The way it happens is there is something called as a service fabric upgrade service that runs as a system service within your service that constantly talks to SFRP and it keeps polling. So it's a poll model where it talks to SFRP and say, hey, I'm in this version, do I need to do anything? And then when SFRP declares that, hey, for your cluster the next version should be blah, then it gets the new URL where to download the new cap file or a deb file based on if you're running Linux versus Windows, and then that drives the upgrade for your cluster. When you choose manual mode, in that case, you are responsible for picking the next available version, and each version has expiry. So if you're not upgrading, then you might end up into an expired version where we say you're out of support and you just need to move ahead.
And I mean, that also puts it on us then to be careful about not shipping breaking changes then, right?
Yes.
Because if somebody sets something to automatic and something comes in and just destroys the way an application works, it's an extremely costly mistake.
Yes. So, I mean, that's the point, right? Like, we should not do any breaking changes.
But we have in the past. We haven't actually.
Before we
GA.
did a public preview
Yeah.
or a private preview, we had bunch of breaking changes.
Yeah. But post GA we haven't,
Post
and
GA.
we can't afford to because
We cannot do that.
yeah.
Sure.
I mean, that's.
But nonetheless, I mean, it should be noted that the general recommendation for a production cluster is still to run with manual mode. And a lot of the times you want your test or your staging environment to have automatic,
Yes.
but you want full control over what's happening in your actual
in the
production. Yeah, so those of you that are listening to this, even though we don't break things, that doesn't necessarily mean you just, like, you shouldn't expose yourself to absolutely everything that comes through. It's always worth testing how things react in the environment. So set your production clusters to manual, but keep your staging and your test clusters to automatic.
Correct.
It'd be a good practice.
So as I was, like, sort of what we were talking about earlier, there's the code that runs on the node.
Yeah, and then there's the
Okay,
code
then
that-
there's SFRP, which is a service
Correct.
that runs in the cloud.
What does that look like?
Basically, you have a gateway service. Let me see if I can draw this. You have a gateway service. Then you have a partition manager. And then you have backend services. So we have 3 backend services, 0, 1, 2. And then the partition manager, basically all the calls from the outside, they go to gateway. They route it to partition manager, and then partition manager makes a decision where that call should go. The backend is a stateful service. Stateful service fabric service that stores a key value pair for your cluster resource, right? And then
What's the key in the value in that?
the cluster ID is a key. The resource ID is a key, and then the value is your cluster resource.
Okay. And so that means that somewhere we literally have a reliable dictionary, I
Yes,
assume,
we do.
of every single cluster that's in Azure that's come through SFRP.
Correct.
So if this is a stateful service, then obviously it can have partitions of its own, right? Like every stateful service can be partitioned. And what's the point of having a partition manager in front of it?
So since we wanted dynamic partitioning, what we did here is we have used backend service as a partition, and then the partition manager picks which partition it will go to. So these are apps that we are directly using as a partition.
But are they further partitioned or they
No,
have just,
no.
okay,
So-
interesting.
So the you cannot have a dynamic partitioning, right? So we cannot scale up if we just have a dynamic partitioning. So that's why we go ahead with, let's say, if we want to add 3.
I see, so if you want to add more, you
if we
can.
want to add 4.
By the way, in the latest set of releases, we are adding the ability
Yes.
to,
So
Yeah.
that's coming, but this is like
had to
3
be built
years
ago.
right?
Yeah. So this is interesting too because you basically just told us that this is a service fabric application
Yes.
that runs, where does it run on a service fabric cluster? So it's a service fabric application that runs on a service fabric cluster from which you create more service fabric clusters.
Yes.
Isn't that kind of circular? How did that cluster exist in the first place? Because I'm assuming it's on Azure, right?
So it's on Azure infrastructure. It's again a service fabric cluster. It runs into Warp cluster where all the other RPs.
Warp being what, like Windows Azure Resource Providing Cluster or something like that?
Something like that.
Okay. I think it's a good guess.
So it has it's a gigantic cluster where you have a bunch of other resource providers, say CRP,
NRPA, XRP.
XRP.
Yeah. What's XRP?
Storage.
Oh.
Xstore.
It's not SRP?
XRP.
Oh wow. Okay.
And some of those RPs are also implemented as service fabric services.
Yes.
I think
All these
almost
are
all of them,
service
yeah.
fabric
So I mean, that's again, when people wonder like, where's service fabric running? Well, it's running in the deepest fabrics of the system.
Yeah.
Yeah.
All of Azure's RPs.
It's pretty crazy.
Yeah. Yeah.
It's pretty amazing.
You've been working on this for quite a while. Obviously, not all of it has been spent on Service Fabric RP. You worked on various components, but since we're talking about this today, what do you think was like some of the more interesting decisions that you guys had to take, or some of the key design decisions that resulted in it being structured like in this way? And if you were to do it again, would you approach it the same way that we have?
That's a pretty tactical question.
You can be as honest as you would like.
No, I mean the decisions that were made based on the best knowledge during that time.
Okay.
So it was like the best possible solution during that time.
Right. So like having a partition manager, for example.
Yeah. So if we had like what do we call that? The dynamic partitioning,
Repartitioning.
or something that.
Yeah.
Then probably we might have designed it in a different way.
And do you think that's something we can ever change? Like, can we ever like change the way SFRP works, or is that not something we particularly care because it's running stably and it's handling the workloads the way that we need them to?
Yeah, it's. I mean, I don't see any need to change it right away.
Okay. Cool, and that's important to know because we're taking a lot of dependencies on it, obviously. It's like all of our clusters on it that are in Azure, and so are a bunch of other RPs that are taking dependencies on the fact that these Warp clusters are running with these search traffic applications, which are all RPs, including the search traffic RP, that are then responsible for resource provisioning as a whole for Azure. So this is a very non-trivial thing, basically, and not something we can afford to mess up.
Thank you.
Thank you for coming and spending time. Deep as always, excellent questions.
Yeah, we appreciate it.
So look, let's talk about the fact that this is an example of a hybrid interview where it wasn't about the core infrastructure.
Right, and
it was about things that you do and take for granted when you create a cluster, and the thing that manages it all. Yeah. And there's a person right there who spends a lot of time coding and debugging. So don't try to reboot those clusters, man. All right.
Thanks so much, guys.
Take care.
We'll be back soon.